After designing the first floor plan, we can add some details and information to the drawing. Let's start with the hatches. I'm going to make a window zoom to have a closer view of the kitchen space. Now, click on the hatches icon and choose the desired frame type. The double scratch requires to indicate the spacing, which I will set to 0.3. One of the advantages of using the wall tool of Dibac is that the enclosures are already defined. Hence, I can choose the area option and change the color to draw blue hatches within the enclosures by clicking on the internal side of the walls. Now I'm going to draw the sidewalk around the house. I can change the color to a darker blue and select the offset tool to create parallel lines at a certain distance to the indicated walls. I want to create lines at 1 meter from the walls, so I type 1 and press enter. Now I click on this wall and then click again on the direction of the offset. I can do the same for the respective walls, which will create a minimum sidewalk width of 1 meter. Now I can connect these lines using the fillet function. Once the function is active, I click on the end of one line and then on the end of the other line to make the fillet. I do the same with the other lines to complete the outline of the sidewalk. To make a hatch inside the sidewalk, I need to use a different method. I click on the hatch icon, leave the parameters as they are, and select the point-by-point method. Now I can change the color to cyan for the new hatch. It's very important to deactivate the orthogonality locking while using the point-by-point method. Now I click on the first corner and then on the rest of the corners of the outline. Make sure to click again on the first corner to define the outer boundary of the hatch. Now I can start clicking on the corners of the inner boundary. Once it's finished, I click again on the first corner of the inner outline. Then once again on the first corner I selected, and finally right-click with the mouse to display the hatch. Note that the hatches are interfering with the lines of the wall. This is because they have been drawn after the walls and are displayed on top of them. To fix this, select all the hatches, go to Utilities, and click on Send to Back. Now it will be helpful to name the rooms of the floor plan. For this, click on the text function. A text height of 0.2 will be okay for this example. Type the name of the room and check the deletion area box. This will hide whatever might be underneath the text to make it more legible. I can change the color of the text before placing it in the center of this room. To create another text, just do a right-click with the mouse to restart the previous function. Type a new definition and place it in the desired location. Then right-click again to create further text, doing the same process. Dibac has a useful function to locate very quickly a text in the drawing. Go to Edition and select Search Text. Type the word you want to locate. If there are more references in the drawing with the same letters, press S to jump to the next text. Now I'm going to start inserting some measurements in the project. But let's hide the hatches first to have a cleaner drawing. Dibac allows you to hide very quickly different elements of the project. For this, go to Utilities and select Activate Deactivate. In the window, you can uncheck the hatch box. After clicking OK, all the hatches of the project will be hidden. With a cleaner floor plan, let's start placing the surface area of the living room. For this, I click on the area icon and select the enclosed area method. This way, Dibac will automatically calculate the area within a closed sequence of walls or partitions. Just click on the internal side of one of the walls and Dibac will highlight the area that will be calculated with this method. If the preview is OK, just place the measurement in the desired position by doing a left click and then right click to confirm. The area function is still active, so you can repeat this action in other room of the project, clicking on the inner line of the wall. Let's see how to create some dimensions with Dibac. I left click to exit the current function and select the standard dimension style. I'm going to use the automatic method, choose a black color, and make sure the orthogonality locking is enabled. If I click outside the wall, Dibac will display the dimensions between every line that belongs to a wall entity. Click outside the opposite wall to confirm the dimensions. Every value is a separated object, therefore I can delete the unwanted dimensions. I can select the dimension to change its color and move it. For this, click on the Move tool, select the dimension, and click outside to confirm the selection. Now you can move it vertically while the orthogonality is locked at 0 degrees. Then click again to confirm the new position. I'm going to create a new dimension style that will ignore distances under 26 centimeters. This way, the walls and partitions dimensions will not be displayed when using this new style. Open the dimension style function and a window pops up with the dimension settings. Click on New and type the name of the new dimension style. Keep the lineal units precision to 2 decimals. Choose the orientation and position of the text with respect to the dimension baseline and type a minimum thickness of 0.26. Using the same color and orthogonality, I'm going to change the current dimension style to the one I have just created. Then I can choose the automatic method. Let's calculate the horizontal dimensions of these rooms. As you can see, the text is too big for the wardrobe space. I could delete this dimension and use a different style with a smaller text, or change the text size of the current dimension style. For this, I'm going to delete this dimension and open the settings of the current style. I decrease the text size to 0.15 and press OK. If I make the dimensions again, the text will be displayed with the updated size. I can left click with the mouse to exit the current function and enable the selection mode to select the 3 dimensions and change their color to blue. Let's see how to create a new dimension style and how to use the continuous dimension method. I click on the dimension style icon to open the settings and click on New. Type the name of the new style, increase the length of the extension lines to 0.3, and change the text height back to 0.2. Finally, I set the minimum thickness back to 0 and press OK. I'm going to change the color to a dark blue and select the new dimension style I have just created. In this case, I'm going to use the continuous dimension method. This method will create a sequence of dimensions with every click after the position of the initial dimension. For this, I have to set the orientation of the dimensions using the orthogonality angle. I want to make a vertical continuous dimension, so I select the 90 degrees angle and deactivate the locking. Now click on the first point of the dimension and then click on the end point of the linear measurement. The vertical baseline with the length value will be displayed, and now I have to move it to the desired position. After doing this, Dibac will keep inserting the following vertical dimensions with every click. The selection by attribute function becomes very handy if we want to select all the elements of the drawing that share the same attributes. For example, I'm going to select all the dimensions of the project to change their color at the same time. For this, I go to Utilities, Selection, and Select by Attributes Objects. Here I expand Items and choose Dimensions. Now I have to indicate the region where this function will take place and do a right click to confirm the selection of all the dimensions. After this, I can easily change the color or make the necessary modifications to the selected dimensions.